12.73 volts while it's running. If we kill the bike, 12.74. So the bike is not charging the battery. With the bike off, we're sitting at about 12.5. 13.13. So it's obviously higher than the battery. That means it's charging the battery, and it's using the stator to do so via the rectifier regulator. The alternator is putting out tons of power and charging this battery. The battery is a little bit low, so it's kicking in even more power, looking at 14.4 volts. It'll generally set around mid-13 once that battery gets topped off. So I'm going to keep this basic. And I realize that alternators can, power spark plugs and whatnot, but I'm not going to get into that. DC system. Battery provides power to the coil right here. Coil turns 12 volts into about 40,000 volts and sends it through to the distributor. From the distributor, it distributes it. The battery obviously is going to drain while it's doing that. The 12 volt system can't handle that load, so the alternator will send power to the battery via the regulator, and it'll power it as needed. Actually, back with the truck, I said the alternator is producing the power to charge the battery. It's not producing DC power. The alternator is no different than a magneto or a stator. It's an AC generator, but the power is being converted to DC. On this mini bike, there's no battery at all. Underneath this flywheel is a wound coil, we'll call it, and when this flywheel spins around, and it creates a magnetic field and produces power, AC power, just like the alternator does. We're inside there behind the flywheel. I don't know if you can see that. There's a little wound coil right there, and that's what's producing that AC power. That power comes out right here, and that makes your AC mini bike headlight work. Completely separate from this coil. This coil is producing power for your spark. That little thing is producing power for your headlight. On the GY6, they're co-located, but they are separate. This part would be down inside the down there next to that part. They're all on that round coil. As the magnet, see the magnet right there, that magnet, as it passes over here, it creates a generating field, just like on these lawnmowers. It's part of this, and it's a trigger coil. And once the trigger coil is passed over with the magnet, it releases, it opens a path to release all these negatively charged ions. Think of this thing like a big storm cloud, and think of it's trying to get a lightning bolt to Earth. So it releases this 20,000 volts down the spark plug wire, and it gets to the spark plug. Now inside here, all these negative charged electrons are coming through the center of this down to the tip, down to that little tip right there, and they're trying to seek ground. So this is threaded into your engine. Your engine is a ground, and this little post right here is a ground, and these things are coming through here at 20,000 volts trying to seek a ground, and they can't find it. So here's your storm cloud, and they send a bolt of lightning to the ground. Boom, right there. There's your spark. So on my mini bike that produces 0 DC power, I want headlights, and I want blinkers and stuff, and I want a horn, so I get them. I get all my lights, all these cool options, and I just hook them to a battery, a 12 volt battery. And that battery is a DC rechargeable battery. I keep it in here, and it just sits there. And I just wear my battery down as I ride it. And if that battery dies, it's not hooked to this mini bike anywhere. If my battery dies, this mini bike still runs. When I get home, I recharge my battery with this little port right here. So to take it one step further, well, what if we could charge the battery with this stator coil magneto system? And we could send the power into a voltage rectifier and turn it into DC and charge the battery while we ride. That would be a pretty good deal. And that's what your Maddog does. Your DC system, just like this mini bike, is a complete different system. We just happen to be charging that battery. There's two separate AC systems in that stator. So when I said this bike wasn't charging, the rectifier is bad. That's possible, but it could be the stator is bad. And if the stator could just be burned out on that side that's trying to carry power. Everyone's seen the stators underneath these flywheels. When you get an 8-pole, you get 7 poles charging your battery and working your headlights and things like that using AC power, and you get 1 pole still dedicated to your spark. When you get an 11 pole, you still have 1 pole dedicated to your spark, and then you have 10 poles charging your battery and stuff like that. Goes over it, and this will send the signal when to release that electricity from that 1 pole. So on your Maddog, that flywheel spinning around your stator, that 1 pole is producing about 400 volts of AC, and that's going into your CDI. That trigger switch on the outside of the flywheel is going to send a signal to this CDI and let it know when to release that 400 volts. From there, it's going to go into this coil. I think we're going to do the 100 times thing again. So the coil's wound to give it 100 times more power, so you're talking about 40,000 volts going into the spark plug. And that's all free of battery. That's all for free. Disconnect the battery, still works. Your battery disconnected and it still runs. That's the advantage of a CDI system. I just started the bike, Kickstarter, and the battery is completely disconnected. And this is what makes that AC system so awesome. If our battery's dead, we can still start the bike and ride it. And it'll produce that headlight power. And now you know why they hooked it to the headlight. So you'd have the bare minimums if you needed it at nighttime to get home with no battery. So it's a great system. That's why it's a vacuum pump. No electricity required. So a very reliable system. Now most of your DC wires are these solid black wires. They're going to work with the bike running or just the bike off with P on. And you can find one of these solid black wires. There's your 12-volt system right there, the 12-volt DC system. DC and AC are two separate systems, if you think of it that way. And I know I've got DC power, but that tells me nothing of the stator's condition or the rectifier's condition. To check the AC portion, I like to turn the idle up as much as I can without the bike taking off. Because the stator puts out more power at higher RPM, less power at lower RPM. I'd like to at least read 7 volts AC to confirm this system's working. The headlight does not go through the rectifier regulator. It comes directly out of the stator. So I'm going to see if my stator is working by checking the headlight voltage. And I've got 9.5 volts AC down there. And that's running at, I don't know, 2,000 RPM? Yeah, 2,000. So I think I would get 12 volts by going fast. Getting the bike at cruising speeds up to like 4,000 to 6,000 RPM. So it looks like to me the stator is working, but it's not charging the battery. So that leads me to the voltage regulator rectifier. A bad ground will also really mess with you. So if you have a multimeter, you put it on the continuity test. You get a tone when you get continuity. So these green wires seem to be the ground wires. On a random green wire and bring it over here to ground. Yeah, and I get continuity. I get continuity. I get continuity. And so I think the ground is intact. Let me go back here to a ground I know for sure on the engine. I don't get a nope, I do get continuity. So yeah, the engine block is your is always your best test for ground. But because it's getting warm while the bike is running, that tells me it is getting something from the stator. It is getting current from the stator. The current's not going anywhere, it's shunting to ground. So we'll do a box swap on this. This bike had a oh, we got the NCY, probably performance, I'm sure. A regulator and rectifier. So this is the original. I'm going to put the original back on and see if there's any difference. One thing about performance parts, they're a lot of fun, but they're not reliable. Most of my bikes have always been, you know, performance parted. But I had a bike that I raced woods race with, enduros, you know, 4-hour races. That's through the woods. Nobody there to help. Nobody heard you scream. When you race an enduro race, a 4-hour race in the woods, you want everything OEM, everything stock. I would never take performance parts in the woods because it's just not reliable. Okay, we've got the OEM regulator back on. We took the NCOI one off, and as usual, aftermarket stuff is junk. It's fun, but it's junk. And now the battery's charging. The 12-volt system is reading 13.5 while the bike's running. That's pretty high, so the stator's probably doing a lot of work. So I don't want to charge it like that. It's really overheats a stator when you have a low battery. A low battery is your #1 killer. And it demands too much draw from that stator, so it heats it up. So always make sure your battery's topped off, your battery's fresh, your battery's good, and it'll charge efficiently. If you have a dead battery that needs to be replaced, don't rely on the stator charging it. It's just going to wear the stator out. Replace the battery. These batteries don't last more than 2 years. Never expect them to. And no matter how much they cost. And always keep a good topped off battery and your stator will be happy. And the trash can keeps filling with failed performance parts. You put too big of a load on your bike. Let's say you have too many accessories on here. The fear is that you'll over task the stator and it'll burn up. And that's partly true and partly not. What happens is the stator produces more power at high RPM and less power at low RPM. That's why your headlights brighter at high RPM, dimmer at low RPM. The problem is, just like a starter and a low voltage battery, you can burn it up. The stator is no different. If you have tons of consumers going and you're trying to demand a load on that stator and you're at a low RPM, it'll still try to give you the power, but you will heat it up like crazy, and that overheating is what can damage the stator. So as long as your 12 volts consumers are going through your battery and your stator is just trying to charge your battery, your regulator rectifier should protect it from overheating. My advice is to keep your DC and AC systems completely separate. So what I did is I snuck out here in the middle of the night, and without my AC system knowing, I put on this stereo and cool ground lights. Everyone told me, oh, you're gonna burn your stator up. No, I didn't tell the AC system I was even doing it. I have that wire just to DC, so it doesn't even know. Yeah, doesn't even know what's happening. AC DC seems appropriate. The headlight, same thing. LED headlights, 12 volts, separate system. All I'm going to do is destroy my battery. All the AC system is going to do is charge my battery. If it can't keep up with the charging, no big deal. The battery dies.